We are still in the geophysical session, and Yavor SHOPOV will present us first successful finding of an outcave by remote location with infrared imaging. Welcome.
Yes, it is not just with infrared. This is with near infrared.
Near infrared.
Yeah. This is another story, and actually it has some advantages relating to the thermal infrared imaging, which was my previous topic. The advantage is that any photographic digital camera is sensitive to the near infrared region, but most of them have musts, because the optics have one focal point in the visible region and another in near infrared. And if your digital camera will see the infrared light with the same sensitivity as visual light, then you cannot focus the image. It always will be blurred, so manufacturers place infrared cutout filter over your sensor. But anyway, even with this filter, any digital infrared camera has some sensitivity in the near infrared, which we used to try to locate the cave. And the idea is that the vegetation reflects very efficiently the near infrared light due to the properties of the chlorophyll. And in fact, this kind of near infrared images are used very widely in the agriculture to assess the degree of percentage of the water in the leaves, or the degree of the dryness of the leaves, or whatever you like to say. Actually, near infrared region is this one, between 760 to about 1000 nanometers, or 1 micron. And here you can see the reflectance of the green vegetation, which is almost 80%, and the reflectance of the dry vegetation in this region.
We don't see the moose on the...
Oh, really?
Yeah.
Okay, sorry. Excuse me.
No problem.
Okay, this is the green vegetation reflectance, this is the dry vegetation reflectance. It is possible to assess the degree of dryness. This is one by photo. Actually, this was this fighter, but never mind. You can see the vegetation on the back. This photo was made on color infrared spectrum zonal film, actually, which is now more expensive than you can buy, because it's not manufactured any longer, but I still have several rows in my fridge. And it gives you the image with the color shift. It represents the near infrared light with a red color. This is the kind of reflectance. Now, this is the structure of any color image. It consists of 3 images at least. One in the blue, one in the green, and one in the red light. That's why you know the photo format RGB. This means red, green, blue. And color vision film is also made by the same approach, and this is actually the spectral sensitivity curve of one standard digital sensor or film, for example. And this is the sensitivity curve of the color infrared film which I show you. And it can see up to the 900 nanometers. Now, these are the color channels which are given on this scale. And this is near infrared, again healthy vegetation and unhealthy vegetation reflectance. And these are some real results, which is a leaf in visible light. This is in picture taken in near infrared with the digital camera. And this is NDVI index. Actually, this is very interesting. This is normalized difference vegetation index, which consists of the difference of the near infrared image, this one, and the visible image divided to the sum of these images. And actually it can be calibrated directly in percents of water in the vegetation. So here you can see the dryness of the edges of this tree, and this is just a leaf which is torn from the tree, and you can not assess visually that it is dry, but the NDVI index gives you the degree of dryness of this thing. What was the field experiment? Again, this was a part of the international program of remote location of caves. Originally, we didn't know that it is possible to locate caves with near-infrared imaging, but I had funding from one project, and we included also near-infrared observations in the project, so we have to check, and I did a great amount of near-infrared pictures like this with a normal digital camera, just with a special infrared filter in the front of the camera. In fact, the sensitivity of the camera dropped down, so you have to use a tripod and several seconds for position time in a clear sunny day. And here on this picture, this is NDVI index calculated from these two pictures, and this is thermal infrared picture. And what is the advantage of the near infrared is that it has almost 10 times higher resolution than the thermal infrared. So here you can see much more details. Now I will show you overview of this thing. This is visual picture of one entrance of one new unknown case, which I located with thermal infrared camera and with NDVI afterwards, and all these entrances of the air were located with NDVI image. You can see here that around the cave entrance we have a significant color difference in the NDVI, which probably is related to the result, the first step, which shows that it can work. But I believe that this technique is very promising because we may take pictures from much higher altitude and to study much bigger regions much faster due to the higher resolution. This is the original picture, and this was the entrance of the cave after first attempts to reach. This was the original view. Actually, this was a Punoro was grown completely by very dense bush. And originally, using thermal infrared, I located that the temperature there coming out of this spot is 8.5 degrees less than the surrounding air temperature. So I cleared a bit the Punor and found entrance of the cave, and this is after some digging. One of cavers entered the cave entrance. It appears to be very tiny, but for sure this is related to much bigger underground chambers which are located in the region. And here the temperature of the air coming from the cave is equal to the average annual temperature, which is 7.6 degrees, and surrounding temperature is more than 10 degrees higher. Yes, I'm almost finishing. These are spectra of different infrared cut-out filters. I use this one, which cuts any light longer than 750 millimeters, almost no visible light can pass through the filter, and this is the top of the sensitivity of the center. So this picture was made in this tiny region, and these are sensitivity curves of standard digital cameras, and you can see that even here there is infrared out filter. There is a small amount of near-infrared light which pass through the filter of the camera. And thank you for your attention. This was
Thank you, Yavor. There are some questions. Yes.
Yeah, I have a couple of questions. Like, normally when we work with remote sensing, the NVDI is the infrared minus the red part of the image.
yes, right.
So we're using the average of the entire image, not only the red, right?
No, we use the red band.
Oh, okay, okay. So,
It was just simplified explanation without many details. Yeah.
Okay.
Sure, we use the red band.
Okay. So yeah, when you go ahead to the research and look drones, I recommend you to use MicroSense 8-band camera.
Yes.
Because they have specific and for example in this one you have an RGB camera and you need to process the image.
You know, I even developed hyperspectral sensors for satellites, so this is no problem.
Yeah, Landsat have the data as well. So
we have even hyperspectral sensors, so we will work more precisely in the future. This was just very preliminary results. Yeah. And this was the result obtained completely from the ground, not from a drone. This was just something unexpected for us, even we were not sure that it can be okay.
Okay, more questions?
I have one. I don't know if it's very basic question.
Yeah, well, it is potentially possible to use commercially available satellite data, but the resolution of this data will be maybe enough to found a cave entrance 100 meters big, but not normal cave. So, so far I am a little bit skeptic for using commercially available NVDI data. This kind of data generally are used for assessment of the health of the forests and of the potential of the forest to burn for forest fires. This is the main application of satellite NVDI data.
And as I'm asking,
Yes.
in the same area, will you use the thermal? Will you do that in the same area that the other investigation did? No, it's a different area.
Sorry?
It's in a different area that you did the NVDI for the thermal cameras that you presented before.
Yes.
Yeah.
This is a different region. This is one very famous cave region in Bulgaria, of Krupni, which was subject of the international program PIJEC, one of the 4 standard karst regions studied by the program of Erasu and Kulina in I don't know how many centuries ago, but it was one of the early programs of UAS.
And would you use them combined?
Sorry?
Would you use them combined, both NVDI?
Yes, sure. Yeah.
Okay. Thank you, Yavor.